Okay, multiplying polynomials together. Let's do this. Let's get this going on. Figure out a way to do it, earn points on tests for doing it right. And again, I'm gonna show you actually two different methods for doing it. One is mimicking how you do it with numbers, and the other is a table method. And both are meant to keep it as simple as possible, because what's going to happen is you end up, when you're multiplying polynomials together, there's a lot of stuff moving around, just like it is when you're multiplying two numbers together. There's a lot to the process. Okay, anyway, the topics here this time are, well, I'm not even, okay, we've got multiplying the two together. That's it. So there's two types though. One is, what if you multiply a monomial with a polynomial? It's not like it's strange or different. This is kind of a simpler case of what we're about to do. What happens in this case is I've got a monomial in this example called 4x cubed, and he's to multiply through with 7x squared minus 3x minus 9. Okay, so the way you want to remember this is this guy outside will distribute, multiply throughout the entire polynomial. Does that make sense? The distributive property? There he is. Okay, so what we've got, therefore, is 4x cubed times the first term. I wrote minus because the second term is negative, so minus 4x cubed times the second term. I could have said plus a negative. Some people like that. And then finally, 4x cubed times minus 4x cubed times 5. So basically, it multiplies with each one. And now you can see why section 1.5 is so important. It told us, we practiced this. Oh, we multiply the numbers together, 28. 4 times 7 is 28. And we add the powers. 3 and 2 make x to the 5. When there's a power missing, it's always 1. You're basically counting how many x's. So 4 times 3 is 12, x to the 3, and one more x is x to the 4, and then 4 times 5 is 20, and it's just x cubed. There's no other x's with it. So the mechanics of multiplication, I want you to study that. Notice, and just pause it if you will, we distribute, and then when you distribute, you multiply the number, the coefficients together, you add the powers. That's big. That's all we're going to do in this whole lecture. Okay, when you get to multiplying two polynomials together, then it gets more complicated, because you got to distribute every term in one polynomial throughout the other polynomial's terms. So if it's a 2 by 2, oftentimes we use FOIL. But FOIL is only good for multiplying binomials together. Like in this case, it could be x minus 2 times 7x plus 3, and someone says first, outer, inner, last. And it's a contrivance, really, and it's only good for binomials. So I tend to go meh to that idea. Over the years, I decided no. Okay, so I'm going to show you two different ways to do it, so that this is kind of a shorter video, although I've got about 5 different problems to do, something like that. Let's do them. This one, I'll show you how it's done. If you know how to do it, great. Okay, the vertical method looks like this. I don't care which order you place it, but you put 1 on top, 3x squared. Where did the e come from? I don't know. Okay, get him out of the way. So 3x squared minus x plus 7 is to multiply with 4x plus 5. Okay? All right. This is how some people do it. This is how some people learned it. And you do it just like arithmetic. You're going to first go with this guy. I'll turn this in red. This guy is going to multiply with all three above. So you go 5 times 7 is 35. And here's the difference. Put a plus. 5 times negative x. In your head, you go, If you know how to do it, you go 5 times x is 5x, but it's negative. And then 5 times 3x squared. In your head, you're going, 3 times 5 is 15. And then there's an x squared. Draw a line, say plus, and then we multiply through with I didn't leave enough room here, so I'm going to erase it and make it smaller. Okay, sorry about that. So it's 35 plus minus 5x, and then plus you can write, if you will, you don't have to. It's the first term, so 15x squared. Then you do the same thing. I'll do this one, the only other color I have apparently, in black. I'm going to go 4x times 7 is 28x, and I'm going to put it underneath the other x term and put a plus in front of it because it's positive. See how tricky this is? Then I'm going to go 4x times minus x is minus 4x squared. I put it here. We indent this way when we do, I was taught to indent when I did long multiplication with numbers anyway, so that's not too strange. And then finally, this one. 3 times 4 is 12, x squared times another x is x cubed. So we have 12x cubed, and we're supposed to add it all together. Okay? So what you do is column by column, just like arithmetic, 35, and there's nothing underneath it, so it drops down plus 35. Then here, you're going to combine these terms, so 28x take away 5x. Don't change it when you're, this is weird. When you multiply, you add the powers. When you add or combine, you don't touch the powers. See how that goes and how people get tricked? This is a 23x, and it's positive. The next one, do you know it? Yep, it's 15 minus 4 is 11x. Don't change the power. And then drop the last guy down. He's plus, and the last guy is 12x cubed. Folks, you're staring at the answer. Okay? It got bigger because we multiplied. If you do it this way, the biggest power you're going to get is 12x cubed. That guy's sitting out in front. But you see what's happening is this 4x is going throughout the entire polynomial in front of him, and so is the 5. Those are the mechanics. Some of you do it that way. That's how I learned to do it too. But through the years of teaching, I'm grabbing more students if I either do it vertically, but even more popular, believe it or not, is the table method. The table method simply says, if I get rid of all this stuff, it says write one of your polynomials, I don't care, horizontally, 3x squared minus x plus 7. He could have been the vertical one. The other one you write vertically, 4x plus 5, and you mark out a table. This helps students that struggle, and that's all of us, so that's all of us do it. Okay, maybe not all of us. All right. Turn this to red. What you do in the table is you fill every box with the product that you see. So if the very first one is the product of these two guys here, 4 times 3 is 12, x squared, 1, 2, 3 x's. There's your 12x cubed. 4 times negative 1 is minus 4, x, there's 2 of them. Okay, we're getting these terms. There's the minus 4x squared that we got in the previous method. 4 times 7 is 28, and then there's an x. You see how cleaner this is? 5 times 3 is 15, there's an x squared. 5 times negative 1 is negative 5, there's an x. And then we have 5 times 7 is 35. Okay, so we have all the terms in the table that we have over here collected in columns. Now, the good thing about the method 1, the first method, is your like terms are all lined up. Well, you know what, actually, our like terms, if you don't want to jump out and list all the terms, which would look like this, right? That's the first row. And then go, what I'm doing is I'm adding and subtracting according to the sign. Should have said something about that. This is what you're getting. If you were to do this number, all that stuff, you'd get all these terms. Okay? Okay, so, but then what you have to do is you have to combine like terms. And in this method, if you string them out, you kind of have to fish for them. Okay, there's a 12x cubed, but wait. What about the x squareds? There's one and there's one. What about the x's? There's these guys and there's these guys. And what about the constant? Oh, there's only a constant there. So you combine like terms that way by hunting for them. But I'm telling you, in the table, you can see them as well. There's the 12x cubed. But then look, if you go diagonally, there they are. Combine them. 15 minus 4 is 11x squared. Again, with the x's, diagonally. There they are again. 28x minus 5x is 23x. 23x. What about the constant? Well, he's sitting there all alone in the corner. plus 35. Voila! That thing is done. Those are the two different ways of multiplying that I think are helpful to students. But of course, as I say, if it ain't broke, I don't fix it. If you know how to do this, just nail the homework down, go crazy. All right, so I think down here, I say, go ahead and do this problem any way you like. I'm going to do the table, but you can do it any way you want to, and we'll see if we match up. I'll see you after you are done working. So pause it and work on this problem. And now we're back. So if I go for the table, it's 7x squared and 4x and minus 3, and it's a minus 3x and a 4. Going crazy with the table. Let's do it. We've got, minus 21x, x squared is x cubed. I can't see that x very well. Can you? Let's make them clearer. Uh-oh. That's okay. We live with glitches, especially this day and age. That's plus 4, and it's a minus 3x. Now I can see clearly. Next one, minus 3 times 4 is minus 12x. X is x squared. Next one, minus 3 times minus 3 is positive 9, and then there's an x. Keep going. 4 times 7, 28, x squared. 4 times 4, 16, x. 4 times negative 3, negative 12. Okay. Let's write the answer. It's equal to, there's the top guy, minus 21x cubed. Going diagonal on it. Really, you're just looking for the like powers, like terms. 28 minus 12 is 16x squared. These guys, 25x. And lastly, minus 12. Who got it right? You? You? High five. High five. Don't leave me hanging. Good job. Okay, so that's that one. And I think these are the last two problems to look at. Yep, here are the last two. Of course, this one is also kind of in the book, the really nasty problems, and then this last guy. All right, I'm going to have you do them, but I'm going to tell you something about the last guy. You know what people do with this all the time? They just go 2x squared minus 7 squared, and I do this to that. I just go, Yeah, I don't, No, it's not. Because when in doubt, write it out. A square means it's multiplied together with itself 2 times. There you go. That's what they call the square of a binomial. So pause it, work on these two problems, and we'll meet at the end, okay? Okay. Here we go. You know me and my table. I'm going to be quiet. I'm going to do this like Marcel Marceau. I won't say one word as I do this at all. I'm just going to work silently. Shut up. Okay, sorry. Marcel Marceau. You guys are young. You know the mimes that everyone hates? Well, he was a mime that was terrific and people loved him. He was so good at it. French, don't you know? Okay. Am I doing it right? Check my work. Oh my gosh, another row. You see, I'm not complaining. Math has trained me, disciplined me. I can take the pain, sir. Oh my goodness, another row. I can multiply all day. Sound off. 1, 2. Going crazy. All right, there it is. I'm going to combine the terms. There's only one of this guy, so 15x to the 5. There are the fourth powers nice and lined up for us, so 20 minus 9 is 11x4. Isn't this fun? There are the cubes, and you can watch this video all day if you want to. I got to add up these numbers. They're all negative. So it's looking like, if I can do this with a calculator, minus 10, minus 12, minus 6 is minus 22 is minus 28. X cubed. Now go for the squares. I got 6 minus 8 is minus 2, 13x squared. And then the x's, 24 of them. And the lone minus 10. How'd you do? Hey, maybe I made the mistake. You never know. I'm going kind of quick with these. And finally, this one. Well, you can FOIL it if you want to. You can do, like I said, you guys can do this any way you want to, but if I continue with the box method, it looks like this. Notice that this is minus 14x again, two of them, right? And then